Okay. All right, so what you're looking at here, these are the formulas for volume and surface area. These are the things we started yesterday. We did a triangular prism yesterday, not a rectangular. Rectangular is way easier. It's just length and width for pretty much everything. Just remember, these are the formulas I'm going through. If you're using these, stick with it, fine. Perimeter, or whatever the base is, so if you have a rectangle, add up the perimeter. Take it times how tall the object is. Now, I don't like the fact they used H. They probably should have used a different letter. Height, what it stands for is the distance between whatever two walls were parallel, whatever you consider the base. So in this picture, they are rectangles. So the bases are the rectangles here, and this would be the height between them, the distance between them. When we did that problem yesterday with the tent, the triangular prism, it was the distance between the two triangles. That's height. Even though it was on the ground, it's still considered the height. Then you take it or you add two of the bases, and that's the area of the base. So if you have the base here, you take it times 2. You add that up. And then volume is whatever the area of the base is times the height. So it's really easy on a rectangle. The pyramid that we did yesterday, whatever your base is, this one's a rectangle here. I think that's the example we did yesterday. This could be a triangle, it could be an octagon, it could be anything. You take half of the perimeter of the base, so the base is a triangle, find the perimeter of it, take half of it. You take it times the slant line. The slant line is if you're on the surface of the pyramid sliding down it. You multiply those together and then you add whatever the area of the base is. So if you know the area of the base, maybe that base was a triangle and you know it, then you find the area of it and you can go from there, okay? The volume is 1/3, so you divide by 3 basically, but you take the area of the base times height. I think we're gonna do one problem today where there's a triangle for a base, and what happens if they don't give you all the numbers that you need. We'll discuss that. I'm gonna give you the numbers that you possibly need for that. I think there's one example in particular we have to look at. Then for a cylinder on this, you're taking the radius times pi times height and times 2. So radius times pi times 2 times height. So you're gonna take that. That's the one we're gonna do today. And then you're gonna add 2 times pi times radius squared. Now what this stands for, like what this formula you're about to look at, why this is the formula for surface area. It is the area of the two circles. The area of a circle is pi r squared, and you have 2 of them, top and bottom of the pop can. And then this part right here, this 2 pi r h, that's the area of the body between it, the actual curved edge. Because if you were to roll out the pop can, you cut off the actual top and bottom of it, the body is actually a rectangle. And the height would be this, and the length of the rectangle body for a cylinder, that's the curve of the circle. It's the circumference of the circle. Because you can see the entire body is the actual curve of the circle. So that's where the 2 pi r comes in. 2 pi r is the circumference of the circle. It's the distance all the way around. And that would be the length. That's why it was 2 pi r times each. So that was the reason why. You don't need to really know that. It's just some people want to know that. Now, I'm just going to do an example of this today. I'm going to do one example of each of these 3, the last 3 today, and then talk about a regular pyramid, something with a triangle, because that's something we didn't do yesterday, and I promised you we'd get to it. But does everyone have their notes? Everything's ready to go? If you need a calculator, I think I have a couple on my desk here. You can go grab one if you need one. They're right on the corner there. But you would want to take notes today. So I'll leave these formulas up when we get to the actual homework today, because you're going to need them. I was going to transfer them there. I totally forgot yesterday. Took off half a year and I forgot to put them on the board. But let's do a cylinder here. Give me any radius that you like.
17.
17. Certain label on that?
Meters.
Meters. I heard meters. Sorry, that was the first time I heard. All right. So it's kind of a big can, a big cylinder. And height.
21.
Okay, I heard 8. Sorry, heard 8. Quick on the draw. All right, we'll use 21 on the next one. All right, so these are the numbers you need pretty much for a cylinder. You just need the radius and the height. That's all you need. And then I can plug it in for surface area. So if you're looking at surface area of a cylinder, here it is. I'm just going to use this formula. There's no other formula I would use. This is just the shortcut. It's doing the body plus the 2 circles. If you understand, that's the 2 pi r h. So the first part, define surface area. 2 times pi times r. The r is the 17 meters. It's the radius of the circle. That's what r stands for. Times the height of the pop can. So You're gonna multiply those. That'll give you the that'll give you the actual body, and then we're gonna add the two circles. So the top and bottom circles are 2 times pi times r squared, and my r happens to be 17 meters, and we're gonna square that. And so this is the formula I was going. This was that second part that I added on. That was the 2 pi r squared. Pi r squared is a circle, but you have two of them, top and bottom. That's why they put the two there. All right, questions with how I plugged in my numbers. So 2 times pi times 17 times 8, right? Now, doing this, 2 times pi times 17 times 8, if we actually multiply these out, what do we have? 34 times 8, and that is a 2 carry a 3, 272? I don't know. Can somebody do the math on that? 2 times 17 times 8?
I got.
Is that right? All right. I can do it in my head. All right. So 272 pi, that's the exact answer. Now, if I want the decimal, I would take 272 times pi. I'm not going to do that. Question?
I got a different answer on the calculator.
Ooh. Take 2 times 17 times 8?
Yeah.
Is there any weird like text on your screen, like it says fix or anything like weird?
Oh.
Did you put pi in there?
Yeah.
Oh, see, I didn't do pi yet. I haven't taken it times pi. You got the decimal. I want that here in a minute. Don't clear that. Okay? Questions on what we just did there? Notice I just set the pi. Now, Cody, you actually multiplied it by pi. What do you get?
I got 854.5132.
Okay, that's good. All right, and that's the decimal. That's this thing as a decimal. This is the exact answer. This is the decimal you get when you actually put in pi. That was good. Thank you. All right. Questions with that so far? Perfect. Now, doing this next part. 17 squared, that's 17 times 17, that's 289. And then you're going to take that times pi, and then take it times 2. Well, the exact answer is going to be 289 times 2, 81271, 578. Pi? Okay. And that'd be the exact answer. Notice it's 578, that's 2 times 17 times 17, and pi. And then if we actually multiply that out, what are we getting as a decimal? Probably in the thousands. Probably almost 1,500, 1,600, 1,700. 578 times pi. 1815.8405 meters squared plus you. Okay, is that what everyone's getting? Did I do my math right? I'm doing everything in my head and trying to anyway. Then we have to add these together. So these are the exact answers. So if you want to add these two together, that's fine. You'd get something pi meters squared, right, because it's area. But then these are the decimal forms. I do want to see the kind of progression that you're making today. Bless you again. But I want to see that you're getting down to the decimal. You know, about 4 or 5 decimal places when you do circles and cones and spheres. Because you're going to have pi, so you're going to have some decimal points. Then you have to add these two together. Geez, what is that? 7, 3, 5, 13 carry a 1. That's 10 carry a 1. That's 6, 7, 16 carry 1. 2,670.
Yep.
Yeah, meters squared. Okay. Questions? Okay, that was surface area. So again, what that means, if you look at the whole surface of your pop can or this cylinder or whatever this is, and you're looking at like individual little squares that were put on the surface, like if you look at the tiles on the floor, so imagine those were like shrink wrapped around the object. You'd have that many of them. That's a big can, big cylinder. Now, not done yet, we have to do volume now. So volume is a lot easier. Volume, pi, r squared times height. All right, there's your volume formula right there. You're only squaring the radius. So in my case, I'm taking 17 meters, I'm squaring that, and then taking it times the height, and your height was 8 meters. Now, 17 times 17 is 289. meters squared. I'm going to take that times 8. So if I take 289 times 8, it was a 2 carries 7, 64 plus 7. 64 plus 7 is a 1. 7 is 1. And 7, or 1 carried over 16 is 17 meters cubed. Somebody double check my math. 289 times 8.
It's 2312.
Say it again?
2312.
Ooh. Did not add that right in my head.
That's all right.
Oh, I had it at 7. I had it at 7 to 16. What was I doing? I had 1. 2312 meters cubed, because volume is cubed. How many little cubes can fit in there? Sugar cubes, right? Now, decimal. Did anyone actually multiply this out? 22 meters cubed. So many little sugar cubes can fit in there if they're 1 meter by 1 meter by 1 meter, like perfect little blocks.
Little sugar cubes?
Yeah, well, they're kind of big. They're
1 meter sugar cubes?
That's a pretty big
That's
sugar.
a lot of sugar.
That's a lot of sugar. It's pretty big. I mean, it's just a meter stick, so.
That's a big sugar
It's a
cube.
pretty big sugar cube. It takes about this whole little block here. That's a lot of sugar.
Perfect amount for your coffee.
Yeah. Yeah. All right. All right. Questions on volume, surface area, anything like that? Well, I'm not losing. I'm just basically all I'm doing is just plugging the numbers into the formula. These, like when you do cones and you do surface area, there's like, especially the curves, like the non-polyhedra, there's not a lot you can do. You just take the numbers I provided you and plug them in. Really, if you just know what these labels mean, I don't even know if I need to walk you through these, because you just kind of know what numbers to use. If we do a cone, you're using radius of the circle, that's R. The L is the slant, so that's the length of the cone, the actual part you hold on to. Right, it's the length of the cone's body. And then the height would be used for volume. So that'd be the H, that's the distance inside the cone, from the top of the cone to the middle, like the bottom of the cone. And then your sphere is just radius, that's all you need. Is there a certain one up here you'd like to see? Do you want me to do a cone? Do you want me to do a cone?
Yep.
Okay, let's do a cone. I don't want to waste your time, but let's do cones. Somebody give me that number. Do we want to use that 21 that we said earlier?
Yeah.
Okay, let's do 21. So here's my cone. Let's say that slant line was 21. And what's the label on that?
Miles.
Miles. That's a very large cone. Okay. All right, so 21 miles. Radius of my cone. It's got to be something in miles, less than 21.
7.
18.
7, hold on. We'll use 18 here in a minute. All right, 7 miles. That's the radius. And we're going to use the 18 as that number. Now, I don't necessarily guarantee that is 18 miles because I'd have to do a little bit of math. But for this purposes, we're just going to use that as the number. I'm not going to check it using Pythagorean theorem or anything like that. All right. I think that's the only 3 numbers we need on a cone. Yeah, you just need radius, height. Height is, remember, from the middle of the cone down to the center where the tip is. And then the slant is that part where you actually hold on to the actual siding of the cone, is the slant line. So, we're going to plug them in. Let's do surface area here first. What's my surface area formula? It is S equals pi times R times the slant. And then you're going to add pi r squared. All right, now let's talk about what this stands for. Some people like to know, like, what are these things? Like, where are they coming up with this? Pi r squared, what does that stand for?
The
Area of circle. So on the cone, this is the area of the top of the circle. Imagine I had like a lid on the cone. That's the area of the top. And then this is the body of the cone. So if you were to roll it out, it's kind of like a fan. It would look like this if you were to roll out the cone. And this represents the actual like area of that little piece, that little fan piece that was cut out. Now, Doing the math, plugging in my numbers, pi, my radius was at 7 miles, and my slant is 21. So 21 times 7, 747 pi. That's the exact answer, and that'd be in miles squared.
Big cone.
It's a pretty big area. And then r squared, so that's 7 squared, right? And then we're going to take it times pi, so 7 squared is 49 pi, and that'd be miles squared. Now, these are the parts, like that stuff should make sense, you're squaring numbers, multiplying them together, right? I do need to know the decimals here, though. 147 times pi, we're in the 400, somewhere in that range, about 400.
147.
650.
1.8.
Wait.
147, not 136.
Okay, 8.
8141.
I got
Okay.
461.
Is that right? Okay, good. All right. Yeah. Got me a little worried. I was hearing different numbers. 49 times pi.
153.9380.
9380. Okay. That's miles squared. Then you'd add those up.
Yep.
Get your number. 1, 2, 1, 5, 7, 1, 5, 11, 1, 6.
I have
Is that right?
Yeah.
Let me just.
Is that right? It's just-
Yeah.
Trying to add in my head on top. All right, questions? All right. Again, this is surface area, so that means if I were to like, how I always think of it is like, imagine you had wallpaper. If you guys even know even what wallpaper is, it's not even a thing anymore, I don't think. But if you had wallpaper and you had like perfect little squares on the wallpaper, like looks like the floor basically, and you like basically wrapped it around the cone itself
Lot
on
of
the surface.
wallpaper.
Yeah, it's a lot of wallpaper, but that's kind of what it looks like. You're like shrink wrapping it with like perfect little squares on the surface. So that's what it looks like. There's 650 of them that would fit. All right, questions? Now, we haven't done volume yet for the cone. Volume. Let's do that. All right, so volume for the cone. So volume is 1/3 pi r squared times h. So r squared, in my case, the r is a 7. We're going to square that. Take it times the height. The height was 18. Then take it times pi and divide by 1/3, or divide by 3, I should say, not divide by 1/3, but divide by 3. So if I do this right, I'm going to take, 18 times 49 divided by 3. You get, let's see, you get, 4, carry a 5, and 294 pi.
Yeah.
And that'd be, what, miles squared? No, miles cubed.
That's a lot of sugar cubes.
49 times 18 divided by 3. It's 294, right? Okay. All right, then we have to take it times pi. Yeah, it's times 3. So you're in the 700s, probably in that range. 900? Geez, even bigger than I thought. 900 what?
9, 23, 6, 2, 8, 2.
6282. And this would be meters cubed. Notice volume is always cubic. It's how many little sugar cubes fit in there. And then area is always how many squares are on the surface. So that's kind of how I remember the labels. Okay, questions with how I'm coming up with the numbers or whatnot? Trying to do it in my head. It's not easy, but trying to do it. Pick some weird numbers. All right. We can do sphere, we can do anything. I want to talk about the triangle pyramid. We didn't do one of those yesterday. I think that's more difficult than doing the sphere. The only difficult part probably about the sphere would be the 4/3. When you actually take pi and cube it, so or the radius can cube, so whatever your radius is, you take it times itself 3 times, then you take it times pi, then you take it times 4 and divide by 3. That's the trick. When you multiply by 4/3, you multiply by the top number and you divide by the bottom number. That's just kind of how you do it. But, is there any questions with any of the ones on the board so far? Maybe I went too fast, you didn't understand something. It basically just comes down to, do you have a calculator? That's really what it comes down to. And do you have the formula kind of written out somewhere?
Well, we have it written out for the test.
Yeah, so test,
So you don't have to.
I'm really tempted to just like have these on the top of the test instead of like having on the marker board. The marker board's inconvenient, you gotta look around and see it, takes time. And sometimes like if you're sitting too far away from that board, it might be super hard to see it. So I'm really tempted just to have that like print on the top of the test or have it like on the, like a back page where it's just stapled to it. So that's what I'm really kind of tempted to do, so you don't have to have it memorized. Because I think it's just pointless having things like that memorized. You can just look it up on Google and know what the formula is. I know on ACTs they would require it, and Iowa Test of Basic Skills, they do require that you have these memorized. All right, good question. Let's do a triangle pyramid. I want to talk about that. I'm not going to go the whole time. I'm going to go about maybe 2 or 3 minutes here. I want to talk about a triangular pyramid. We didn't do one of these yesterday. We did a pyramid. It was just rectangular. The bottom was super easy to calculate. All right. So I'm gonna try my best to draw this. It's gonna look terrible. All right. So imagine that this is your pyramid. Oh my God! I should not put that line right there.
Do we have an assignment today?
Yes, you will. All right, so here is my, oh, yeah, that'd be a dash on the back. These would be dash, you wouldn't see these. Those would be in the background. Okay, so, it still doesn't look great. Maybe I should just stop drawing it in 3-dimensional. There, here's your pyramid. It's supposed to be triangular. You got, there. You got this front, you got this front, and then there's the back wall. It's triangular, it's got the base as a triangle. Sorry, this is a better drawing than that crap. All right, so let's imagine that the bottom was a regular picture, right? So the bottom is regular. So let's say that the base of my little pyramid, which has 3 walls, you can see the base here. The base looks like that. That's the bottom. So if you're looking like straight from the bottom, that's what the bottom looks like. Let's say that they're all 6s. Let's give them like 6 inches. Okay. It is an equilateral triangle for the bottom because it has to be regular. They say it has to be a regular picture. So it has to be whatever the object you're dealing with has to be a perfect shape. So that means on the big picture, these would be 6s, right? And the 6 would be also on the back wall on the bottom of that ridge. All right, now the other thing that you need for the pyramid is you need the slant. The line going down the slant. So if you were like on the surface of the pyramid and you're sliding down it, that's a slant. You're actually like riding the surface all the way down. It's not the inside of the pyramid, it's actual slant itself. Okay? Let's say that slant was, let's go like 10 inches. That was an inch. Okay? And height, let's say the height of my pyramid, just gonna make up a number here. The height of the inside of the pyramid, we can throw that number in later. I'll just put it off this side. Let's say the height of this pyramid is,
12.
Nah, it can't be more than 10.
9.
9? No, let's go 9. 9 inches. That'll work. It can't be more than 10. The slant, when you ride the surface on it, has to be a longer distance than how tall it is. So, all right. So the height of the pyramid, if you're on the inside of the pyramid looking straight up, the height is 9. The only real other number we need is the base. Because if you look here, we do have to find the area of the base at some point. The base on this particular pyramid was a triangle. It was an equilateral triangle. So all these other numbers make sense. You have slants, you have that perimeter. This is the height of the pyramid, but we need like the actual number for in here because this is an equilateral. It's not a right triangle. You're not going to take 6 times 6 and cut it in half, right? That's not how you find it. Because we actually need to find the wall in here, like the 90 degree for that base triangle, the bottom triangle. So I'm just gonna give you that number. Let's see, do I have a calculator here? Here, maybe somebody can do it.
Nathan Solon.
Okay, take 36, subtract 9 for me. So 36 minus 9, what is that? 27. And then take the square root of that. It's gonna be 5.3 or something like that. Square root of 20.
1,
Say it again.
5.19.
5.1?
Yeah.
Okay, and let's call that inches. I want to make this kind of accurate, so. All right. So let's say that's the height of my triangle, or the altitude of that triangle. That's the bottom, right? This is the base. Whatever label. That's the base. That's the bottom of that thing. Everything else is the top. I'm not really caring about that. All right, so let's do some numbers here. I didn't do one of these yesterday. I did promise you if we'd come back and do a triangular pyramid. I think it was kind of important we get to see one of these. All right, so let's do the formulas here for your pyramid. All right, so surface area, half times the perimeter times the slant, and then you're gonna add whatever the area of the base is. Okay, so what is the perimeter of my bottom of the base of my pyramid?
18.
18, right? So it's half times 18. Again, perimeter is just the outside of the walls. The bottom of the thing was 6 by 6 by 6, so 18 makes sense. The slant, how far did I slide?
10.
10? That was 10 inches. And then we're gonna add the area of the base. Now the area of the base on a triangle, you're just gonna multiply those two numbers. The base times height, and then cut it in half. So if I were to multiply 6 times 5.1 and then cut it in half, you should get 15.3.
Yeah.
Inches squared.
If you could do it just so then it's 30.6.
Yeah, so it's the area of triangles are always base times height and cut it in half. That's the area of a triangle. So the base was 6, the height was 5.1. Now, if I multiply these together, that is 18 times 10 is 180. Divide by 2, that's 90 inches squared. And add that to the 15.3 inches squared. And you should end up with 105.3 inches squared. Square inches there. Questions with how I did that? Usually the numbers will all be provided to you. Or whatever the base is, they usually provide all the numbers for you. The science provided, the height of the triangle is provided. I haven't even used the height yet. Is there any questions with the surface area though, how I did it? I think the hardest part was the base. You had to know it was a triangle, so you had to go base times height, cut in half. All right, volume. Let's do that. Volume of a pyramid, it's 1/3 base, whatever the area of the base is, times height, right? So we did the area of the base, right? We did that earlier. The base was the 6 times the 5.1 cut in half, so it's the 15.3 inches squared. Again, the area of the base is base times height cut in half, base times height cut in half. That was the bottom of my pyramid. Now, what is the height of our pyramid?
9.
9. That was the height. That was the inside of the pyramid. They usually provide it to you off to the side, so that was 9 inches. So if I multiply these together, I should get a 9, 15, 1, 45.9, just cubed. That's 15.3 times 9 divided by 3. Let me double check my math. Questions? Notice it's cubed, right? So many cubes, that's volume. It's always cubic. Area is always in squares. So, all right, I'm gonna leave that on the board. Here's your homework this week. That'll be due on Friday this week. Yeah, due Friday. You have a couple days to work on it. It is 5 problems, one of every type.
Only 5 problems.
5. Good choice on the 10 for the slant line, by the way. On your pyramid. I need to keep it on.
Me? Yeah.
Yeah, good choice on the 10 for that slant line for your pyramid. The one number you need to add to this, because I didn't think about it, and you guys did a real nice job picking a 10 here. For your pyramid. Do you see your number 2 on that? 6 by 6 by 6. It's a triangular pyramid. It's got a slant of 10. Good choice on the 10, by the way. Your height is the only difference. So
Yeah, I noticed
height on
that.
yours, it was 8. You guys picked that. The one on the worksheet's 8, I think. That's
Yeah,
supposed to be 9.
it's 10.
You're still going to use this on the bottom of that pyramid. You have to use 5.1. That's why I had to do that calculation for you. I forgot to type that in there. I forgot to put that in there as a label. So this is on that base of that pyramid on number 2. You have to use 5.1. That's the height between the walls. So that's how you calculate the area of the bottom. You have to use 5.1 on one of the 6s to find the area of the base of the pyramid. So I forgot to type that in there. I was going to put that in there.
Wait, so what, no,
That's, so on that pyramid, so this is number 2, right? So you're looking at your pyramid on number 2. It's, so here's, they have this.
Same.
You're using, this is 5.1 right there. It's, so that way you can figure out the base and height of that triangle for the base to figure out the area of it. I forgot to give you that number. I forgot to take it in.
Wouldn't the surface area be the same then?
Do we change the height?
No, the height is how tall it is, so you're gonna use 8 for yours. I used 9 up here.
Wouldn't the surface area be the same then?
Yeah. Yeah, your surface area is the same. Yeah, because nothing changed. Because the perimeter was still the same, your slant was still the same, your base was the same as the one on your picture. So that should be the same number as your surface area for number 2. The only thing that would change is volume. The reason why volume would change is your height is different. You had 8, so this would be the only number that would change. So it'd be slightly less than 45.9. So yeah, good point. Okay, this is due on Friday.